Hi, so let's discuss circles. So most of you know the circle's definition. A circle is a two-dimensional geometric shape consisting of all points in a plane that are equidistant from a fixed point called center. The definition is not very important. We know the property, right? Any point on the circle, its distance from the center is radius r. Like, you can't say that this is circle. Why? Because whatever is the center, these are all different distances. So this is not a circle. So radius is again from the center of the circle to any point on the circle. The distance between them is radius. Now, if we double this, we extend this line segment on the other side, this is called the diameter, right? This is called the diameter. So which is 2r, right? Diameter is r plus r, 2r. The next one is circumference and area of circle. Again, all of these are formulas that you'll need to remember. Circumference is pi multiplied by d, or d we know is 2r. Circumference is 2 pi r. And area of circle again is pi multiplied by r square. So question, if the area of a circle is 64 pi, so what is area of circle? Pi r square. This is equal to 64 pi. Find its diameter and circumference. So if we solve, what do we get? R square is 64, which is equal to 8 square, right? So r is equal to 8. R cannot be negative. So radius always has to be positive. So if radius is 8 units, what is the diameter? Diameter is 2r. This 2 multiplied by 8. And circumference is 2 pi r. This 2 multiplied by pi multiplied by 8, which is 16 pi. Again, these are straightforward questions basis the formulas. Now we'll see what is called arc of a circle and sector of a circle. So let's say if this is the full circle, and if I cut this into two halves, right? The lower half is cut. So what remains is the upper half, and this is called the semicircle, right? Half of the circle is called semicircle. And let's say if this total circumference is 16 pi, because diameter is 16 and circumference is pi d, which is 16 pi. Half of this circle or semicircle's arc length is 8 pi, half of 16 pi. So you need to understand what is arc. Arc is this, the curve, right? So what is arc of a circle? Arc of a circle is a portion of this circle's circumference, whatever portion is there. So this is the full circumference. And this is half circumference. So that is called arc. Now, the next definition is called central angle. So what is central angle? Central angle of a circle is an angle formed by two radii extending from center of the circle to 2 points on its circumference. Again, this is not very important, the definition. What you need to understand is, you just see how much portion of the circle is there. If the portion is entire, the central angle is going to be 360 degrees. Because what portion of circle is there? Full circle is there. If there is full circle, central angle is 360 degrees. Now, in the second figure, there is only half circle. Of half circle, this is the angle subtended by the arc, which is straight angle, we know is 180 degrees. Or half circle is half of 360. Now in the third figure, if you see, there's only 1/4, right? Because 1/4 of the circle is remaining. So 1/4, what will be the central angle of this arc is 1/4 of 360, which is 90 degrees. So you just need to see what portion of circle is there, okay, and what is the angle subtended. If you know the fraction, you know the full angle 360, you can find the fraction of that angle. For example, if they say angle is 1/6 of the total angle, so 1/6 of 360, which is 60 degrees. Now coming to the formula, arc of a circle. Arc of a circle is this curvature length, which is AB, is fraction of the angle subtended by this arc to the total angle multiplied by the total circumference. Okay, how did this come? Let's say if 360 degrees corresponds to entire circumference, theta corresponds to what arc length? Okay, so how do we get theta into 2 pi r upon 360 using the unitary method? So this theta upon 360 corresponds to the fraction of the circumference and fraction of the area. That is called area of sector AOB. Again, something like this, right? Had this been entire, this theta would have been 360 and area of sector would be pi r square. Because this is some fraction, so you will need to take only the fraction of the entire circle, which we call it as area of sector. Okay, we'll solve some questions. A sector has a central angle, which is, let's say, theta of 120 degrees and radius of the circle is 3. Find the arc length. What is arc length? Is theta upon 360 multiplied by 2 pi r, which is 120 upon 360 multiplied by 2 pi into r. So this cancels 3 times and this cancels once. So 2 pi is the arc length and area of the sector is theta upon 360 multiplied by pi r square, which is 120 upon 360 multiplied by pi into 3 square. Again, this is 1/3, 1/3 gets cancelled. So area is 3 pi square units. Okay, one last question. A sector has an area of 4 pi. So what is area? Sector area formula, theta upon 360 multiplied by pi r square. This is given as 4 pi. And r is 4. Find the arc length. So they've given r, we can find theta, right? Theta upon 360 into pi into 4 square is equal to 4 pi. So these two gets cancelled. 4 gets cancelled. And another 4 gets cancelled in 360 by 90 times. So what I have is theta upon 90 is equal to 1, the right hand side, or theta is 90 degrees. Arc length is theta upon 360 into 2 pi r, which is 90 upon 360 multiplied by 2 pi into 4. 4 gets cancelled. I get 2 pi. 2 pi units. So this is how, knowing the formulas, you can directly solve the questions. We have discussed what is circle, radius, diameter, circumference and area of circle, then arc length and sector of the circle basically. So that's about the circles, and I'll see you guys in the next session. Thank you.